All right, so welcome to another segment of physics O level. This time we are focusing on looking at some examples on how we can apply the thin lens formula, or the thin lens equation as I'm referring to it, and also how you are able to calculate the magnification. Right, so if you look at this example, I've got two examples, this question there and another question that came from the 2024 paper 1, ECZ, Examination Council of Zambia, question. You'll be able to see it in just a short while. So the question there says that a thin convex lens has a focal length of 12 centimeters. Determine A, the characteristic, or if you want, the properties, B, the position. Then C, we can talk about the magnification when the object distance is 18 centimeters. So Roman 1, we want to do that when the object distance is at 18 centimeters, then Roman 2, when it is at 4 centimeters. So I'll look at 18 centimeters, then in your own free time, you can actually get to practice with the 4 centimeters that is there. All right? So we can therefore say, as we always tell you, it is always important to list down the information that you have been given in any physics question. So we can look at what data do we have from there. So from there, they have told me the focal length in this case. So the focal length is actually 12 centimeters, which is a positive 12 centimeters if you want. And they have given me the object distance, which I'm using 18. So when your U is equal to 18, that's a positive 18 centimeter. Now the question says we determine the characteristic. Now in order for us to determine the characteristic of the image formed, we need to know what is the image distance, and that is what we don't know. So we apply the lens equation here. So in my first one there, in order for us to know that, we need to apply the lens equation, which says 1 over the focal length is equal to 1 over the object distance plus 1 over the image distance. So it will be 1 over the focal length. We know that is a 12, which is equal to 1 over the object distance, which we know is 18, plus 1 over v, which we don't know. Of course, using simple mathematical gymnastic, like terms on one side, we can take 1 over 18 to the other side. So that is going to be 1 over 12 minus, when it crosses, it will become a negative. 1 over 18 will be equal to 1 over v there. We can find the common denominator where, in this case, 12 and 18 can go into. So the lowest common denominator where those can go into, we can talk about is 36, because 12 goes into 36 how many times? It actually goes there 3 times. So it will be 3 minus 18 goes into 36 2 times. So 2 multiplied by the one on top will give me a 2 there. Please allow me so that I can just use that space. There's no problem. You can start with 1 over v is equal to 3 minus 2 will give me 1 over 36. Then to find v, you can cross multiply. If you want, you can say v is equal to, you just invent that by this going up and this coming down, which will be 36. But let's do the normal one. We know we cross multiply. V times 1 will give me v is equal to 1 times 36 is actually going to give you 36. It is going to give you 36 centimeters. So meaning that the image distance from the lens is actually 36 centimeters. Now if I come to that one, the question was saying determine the characteristic. So using that, we can actually determine the characteristic. Remember what we said, when v is positive, it simply means that the image formed is 1, it is actually real. Then 2, it simply means that it is inverted, meaning that it is upside down. Then it simply means that it has actually been magnified. it has actually been magnified. So those were the characteristics that we can state by, first of all, finding what we are calling as being the image distance. B was simply saying the position. So what's the position? I'll just write my B there. What's the position? Well, the position, they are telling you where it is located. Well, the image is actually located, the location of the image is what we found there. So it is actually located 36 centimeters, from the lens. But of course, we know it is on the opposite side of the object. So it is actually located on the opposite side of the object. Why? Because this value we calculated is a positive value. So it simply means that it is located on the other side. C there says we calculate the magnification when we calculate the magnification at when the object is that. So since we know V and we know what U is, we can calculate magnification. Allow me just to flip so that I can actually get to show you. So remember what we said, magnification, linear magnification is equal to image distance divided by the object distance. We know V is actually 36 centimeters. We know U, which is equal to 18 centimeters. So we can calculate the magnification there. So linear magnification will be equal to the image distance, which is 36 centimeters divided by the object distance, which is 18 centimeters. So therefore, magnification will be equal to, 2. That's our magnification. So therefore, we can simply say, the image is magnified. So the image is actually magnified 2 times. So it is actually magnified 2 times. That's what we mean. As some write it, or it is actually magnified 2 times. That's what we mean. So that is how you can calculate, that question using the thin lens equation. Now there was another question that came, last year in the 2024 paper 1, question C1b in the ECZ exam. This is the question. I just isolated, a part of the question so that I'm able to demonstrate it to you, so that in your own free time, you can also take time to pass through using the lens equation. So it says an object is placed 30 centimeters from a biconcave lens of focal, it's like I touched somewhere here, of focal length 20 centimeters. How far is the image from the lens? So again, how far is the image? In other words, they're asking you to calculate the image distance. Then the second one was saying state whether the image formed is real or virtual. So they want you to state whether it is real or virtual. So now in the first part there, how do you go about it? Well, you need to calculate. In this case, they have given us where the object distance is. They told us it's 30. They have also given us the focal length, which is actually 20 centimeters. But what we don't know is the image distance, and that's why the question says how far is the image from the lens. So we need to calculate our V there. So we need to apply the lens equation. 1 over F is equal to 1 over U plus 1 over V there. So it will be 1 over the focal length, which is 20, is equal to 1 over the object distance, which is 30, plus 1 over V. So again, the like terms on one side, so this will go the other side. So it will be 1 over 20. When 1 over 30 crosses the equal sign, it will be 1 over 30 is equal to 1 over V. Now if you notice, I can still start with that one. We can find the common denominator there, the lowest number where 20 and 30 can go into, which is 60. 20 into 60 goes there 3 times, times 1, that would be a 3, minus 30 into 60 goes there 2 times, times 1, which is a 2, which is equal to 1 over V. 3 minus 1 will give me 1 over 60 is equal to 1 over V. Like I said in my previous one, how do I find in this case what we are calling as being, a V, the image distance? We are just going to cross multiply. Sorry, allow me just to erase. It's like my space is actually worn out. So I'll just clean up the top part so that I can finish up the problem from the top. So again, if we cross multiply from the bottom here, it will be v times 1 will give me v. It will give me v is equal to, so v is equal to 60 times 1 will give me 60 centimeters. Remember, this is a positive value. So that is how far the image is from the lens. It is actually 60 centimeters. That's what I wanted you to do in that exam. Now the question B says state. They want us for this question, they want us to state whether the image formed is real or virtual. Remember what we said, when your image distance is a positive value, the way we have gotten a positive value, it simply means that the image, formed, it simply means that the image formed is real. Why? Because V is actually positive. So our V is actually positive. So when your V is positive, your image distance is positive, it simply means it is real. But if our V, the image distance, was a negative, it simply means that it was going to be virtual, not real, meaning that it cannot be formed on the screen. Well, this is the end of this topic that we had. In our next discussion, we are going to focus on magnetism. Thank you so much for watching my videos. Please, subscribe, like, so that we can produce more videos.